Can you help me?
Yeah, in this project we're going to do the problems 28 and 32 from the first partial lab. First, we're going to write all the information in here.
The information we have is that the probability of A is 35%. The probability of A and B is 10%. And the probability of not A and not B is 20%. To help us solve the problem, we decided to do a Venn diagram. So we added the A and B probability in the middle because this represents the intersection. Then we subtracted the 35 minus 10, that is the intersection, so that will be 25. And the 20% that we have here, we put it outside the circles and then we boxed it. And to find B, we would sum 25 plus 10 plus 20, that will give us 55, and then we subtract 100 minus 55 and we would get the 45, that would be the B.
Mr. Krabs, I am so confused.
And we subtracted the 100 from the 55 because the 100 will be the total.
First question, we need to take out the probability of B. And we know it's 55 because if you can see in the Venn diagram, we have the 10% that is the intersection of A and B, and the B that is 45%. So what we need to do is to add these two, and we're going to get 55.
Wait, what is that?
In question number 2, we're asked to find the probability of A or B. So what we will do is use this formula, the probability of A plus probability of B minus the probability of A and B. So with the help of the Venn diagram, we know that the probability of A is 35 over 100 plus the probability of B, that is 55 divided by 100 minus 10 over 100. This would give us 4/5, and in percentage that will be 80%.
In question number 3, we're asked to find everything that is the probability of everything that is not A.
How do I do that? I'll show you.
So we're going to exclude that 10% because it's the intersection of A and B. That means that is also part of A and the A itself. So we're going to add 45% that is B plus the 20% because the 20% doesn't belong to the circle of A. And your answer is going to be 65%.
This is really good stuff, isn't it? Hey, you know the beauty of this is? It works every time.
In question 4, we're asked to find whatever is not B. So if we look in the Venn diagram, we should exclude everything that is part of B. So that will be the intersection between A and B, that is 10%, and the 45%, that is B itself. So if we add 25 plus 20%, we would get the 45%.
Whoa, dude, stop, you're blowing my mind.
What are those?
These are the 3 formulas that we are going to use in this project. The first 2 are really similar because are to find the conditional probabilities. The first one is to find the probability of A given B, and the second one to find the probability of B giving A. And the third one is to find the probability of A or B.
Now what?
In question number 5, we're asked to find the probability of A given B. So, we're going to use this formula, but we can also do it visual because we have here the Venn diagram. So, first we're going to look for the intersection of A and B, that is 10. So we're going to put over here 10 over the probability of B. So if you sum 45% and 10%, it is 55%. So we're going to write here 55. And this is equal to 18.18%. That is this.
In question 6, we're asked to find the probability of B given A. So we can use this formula, and with the help of the Venn diagram, we know the probability of B and A, it's 10%. So we write this down. And then the probability of A, it's the sum of 25 plus 10, and that will be 35. And the answer is 28.57%.
Kind of seems like you get it.
Permutations are the number of different ways in a certain amount of items where the order can be arranged. And combinations are the number of different ways where a certain number of items can be selected as a group. So permutation, the formula is this, where N means the item taken out of R, and in combination the formula is this, and it's where we choose our items out of N. And when repetition is allowed, it is only allowed in permutation, and it's choosing R out of something that has different types.
Oh my God.
The problem we had to study was the problem 32, where it says 12 students are competing for 3 exactly identical scholarships, and this problem is a combination because in the order in which the scholarships are assigned doesn't matter. The scholarships are so identical so that they can get the same. To analyze problem 32 and it says that 12 students are competing for 3 identical scholarships for university. The problem is a combination because the order in the scholarships doesn't matter, and also they are identical, so they all get the same thing. So the question of letter A is how many different ways could its winner form? And in here we need to identify the N and the R. In this case, the N is the total of students, which is 12, and the R are the scholarships, so it's 3. And the way we're gonna place the formula in our calculators is 12C 3, which will give us a result of
Oh.
So there are 220 ways in which we could determine the winners of the scholarship. And the question B is, if Roberto's performance is that good and the scholarship is guaranteed, how many different ways could its winners form? And here you're sure Roberta is getting a scholarship, and because of her capacity, so we're gonna subtract -1 scholarships. It's gonna be R equals 2, and we're going to subtract also a student because she's like she already obtained it, so it's gonna be N equals 11, and we are gonna put it in the calculator like this, and the answer is 55 ways.
All the work is right and just the answers are wrong.